Hello, you are watching the show that I make when I find something cool that I want to discuss, but I don't want to put a ton of effort into it or make a big animated slide deck. Today we're going to be talking about function inlining. So I was gathering some data for the next episode of Terminal Velocity, and I was running the textbook matrix multiplication algorithm, or you might hear me refer to it as the naive algorithm. And I was noticing that I was having some consistency issues between different versions of the naive algorithm that I was doing. So my run-to-run consistency was good, but when I was compiling and running a file that just called the textbook implementation from main, and it was just doing that, it was running quite slowly. Whereas if it was calling the textbook or naive implementation from Strawson's algorithm, that is, main calls Strawson, calls naive, given a certain condition, it was running quite quickly. So I disassembled both of these binaries, and I found that, interestingly, the binary where the textbook implementation was being called directly from the main function, so my naive file, was not getting inlined. And I noticed that for the version that was being called from Strawson's algorithm, so main to Strawson to textbook or naive algorithm, it was getting inlined, and it was also getting compiled to AVX code, which is obviously significantly faster than non-AVX code. So this kind of stumped me a little bit, and I was trying to figure out what the root of the issue was. So I found that if you just directly call that textbook implementation, it does not get inlined. And then if you proxy that call through another function, so main calls foo, and then all foo does is just return a call to the textbook implementation with the same arguments, it also doesn't get inlined. And that was interesting because I figured, that might be part of why it's happening. Obviously, it is getting called through Strawson's algorithm when it is getting inlined. And it is also not getting inlined if you add a really trivial if, like if 1 is greater than 0 or something like that. I figured that might also be a reasonable step to test because it is getting called in an if statement in Strawson's algorithm. And then I found that if you create an if statement that has a condition that's only true at the call site where you are calling that proxy function, so if main calls foo with, for example, an argument that is constantly 8, and then you say, if that argument is 8 in the proxy function, and then you call the textbook implementation, it'll inline it there in that specific case. So I'm thinking what's going on here is that you're probably involving a much more advanced optimization pass when you're doing that, and that might cause the function to get marked for inlining if you are, I guess, involving that in that area. So that's just a guess, though. I'm not entirely sure why it's doing that. Obviously, if you make these functions all static or you enable LTO, this will get inlined really trivially. And if you enable LTO, it won't even emit the textbook implementation into the assembly or the object file. So that was pretty interesting. I'm not quite sure why this happens, actually. My guess is it has something to do with either the really advanced optimization pass causing it to be marked, when you're using a lower, or I guess a less advanced optimization pass and you don't need to invoke that advanced bit, it doesn't get marked. It could also be because of ISA compatibility, but again, I'm not entirely sure about that because it would seem that you could inline the AVX version of the function and then just keep the non-AVX version in the binary to be called by whoever. So yeah, I think the moral of the story here is that optimization is fickle, life is short, always check your assembly before you benchmark it, and keep subscribed to Code Points so I can drop more ways that GCC tries to make your life interesting. Or in this case, probably protect you from something that you don't realize could be a problem. So thanks for watching. Hit those engagement buttons. I'll catch you later.